Okay, in this video, I'm going to be talking about some basic integration rules. And now, while this isn't formally a topic that's in AP Calculus, I think it is a good topic. It reiterates a lot of what we've been talking about. There's a lot of U substitution and, quite honestly, just a lot of fun integrals in this section. So the first example, understanding the difference between how we would approach each of these integrals. Each of these integrals is very much an appropriate question for AP Calculus. So how would you choose to do each one? Well, the first one, that one kind of looks like an inverse sine. So if I take the 2 and I put that outside the integral symbol, I have 1 over the square root of 1 minus x squared dx. Well, yes, that's inverse sines. So I end up with 2 inverse sine of x. And don't forget your plus c. Now, the second one. So the bottom kind of looks like an inverse sine, but you have that 2x on the top. So let's try maybe a u substitution. So if I make u equal to 1 minus x squared, du is equal to a negative 2x dx. Well, I have most of that here. I just need a negative inside, negative outside. So that turns that to the integral of negative 2. We have a du on the top. And we have our u to the 1/2 power. I like to write that a different way. It just helps me visualize and get the correct answer. So I write that as u to the negative 1/2 du. Okay, so then I have the negative of u to the 1/2. 1 over my new exponent. Oh, I got too aggressive. I need to erase that and put in a 2. My u is 1 minus x squared. And then don't forget your plus c. Now the last one kind of looks like an inverse tangent, but to be inverse tangent, you'd have to have 1 plus x squared. And you also have the 2x on the top, so that can be deceiving. So that one's also a u substitution. And make sure that you write your u substitution correctly. So my du is negative 2x dx. Okay, so I need a negative and a negative. So I now have the negative integral of 1 over u du. Well, that's the negative ln of what was inside plus c. By inside, I mean what my u was. And we get that. Okay, example 2. Now this one's kind of a fun way to do it. I'm going to switch to a different color because I like this one. That's the color I wanted. Okay, I just wanted my little toolbar to go away. Okay, so on this one's kind of a fun way to do this. And I'm going to work through this without those integral limits and then add those in at the very end once I've done all the integration. And you're going to want to save some room for this one. This one took me about a half of a page. So I'm going to look at this one. And u substitution doesn't work here. Because if I make my u x squared not plus 16, x squared plus 16, then my du is 2x. Well, I have x minus 7 on the top. So we have to manipulate this. So the fun way to manipulate this is to do the integral of x over x squared plus 16 minus, don't forget your dx. See, I can slip it there in the end. There we go. 7 over x squared plus 16. Now, each one of those is its own kind of little animal. So the one on the left is a u substitution. I'm going to go through that u substitution kind of quickly to kind of save myself some time in my video. So I need a 2 inside, 1/2 outside. So then eventually that turns into the integral of du over my u. And don't forget the 1/2 that you had. Okay, so now that other one, the one next to it. Okay, so that one's a little bit of work. So that looks like an inverse tangent. So what I do, and I'm going to kind of do it over here at the very top. So I'm first going to make this -7 integral of this thing. So I have the integral of 1 over x squared plus 16 dx. So what I do is I take out the 16 and I get a 1 plus an x squared over 16. I'm trying to do this too fast. I also haven't recorded a video in probably about a year. So that's kind of fun. Dx. So then I have my integral of my 1/16. 1 over... Remember, I do this a little bit differently. Some books, if you want to memorize those formulas, that's fine. I don't have the brain power. I think if I understand how to do it, that would make me a lot more successful. I'm going to make W. Since I already have U in the problem, I'm going to make W equal x over 4. Now, some of you are going to be able to do this in your head. dW is 1/4 dx. So I need a 1/4 inside, so I have a 1/4 outside, a 1/4 inside. I just split that 16 into 1/4 times 1/4. So then I have I don't need the 1/4 because the 1/4 gets put into my dx. So I have a du 1 plus w squared. So this second one simplifies to be a -7/4 integral of dw plus 1 plus w squared. So then, taking that up over here, so I have 1/2 ln of my x, which was x squared plus 16, minus 7/4. The integral of that other piece is inverse tangent of my w, which in this case is x over 4. And now remember, don't forget about, circle them in yellow, don't forget about those integral limits. We have to add those in now at the very end. And ooh, this got me because I made a mistake. Because I wasn't thinking, but that's okay. So now I plug in 4. So I have 1/2 ln of 32 minus 7/4. The inverse tangent of 1 is pi over 4. Where does the tangent equal 1? Then I plug in 0, so I get minus 1/2 ln of 16 minus 7/4 times the inverse tangent of 0, which is 0. So let's kind of look at our like terms, or what we might be able to make like terms. So I just kind of rearrange things a little bit. And don't forget your pi. Okay, if I factor out a 1/2, remember with natural logarithms, if you have the same base, you can write that as ln of 32 over 16. So 1/2 ln of 2 minus 7 pi over 16. Woohoo, and I got that right. Okay, this next one's, again, another fun one. I'm just going to leave my colors up there. I apologize. I don't know if I always like having that up there. So that bottom piece, the whole integral, looks like the square root of 16 minus something squared dx. What is that something? That something's going to be x to the third. Okay, so now here's the fun part. If I make my u equal to x to the third, du is equal to 3x squared dx. So I have what I need. So then up here, I have mostly what I need. Man. Okay. Multiply by the 3 inside, 1/3 outside. So then I have 1/3 the integral of du over the square root of 16 minus u squared. Now again, my trick, if you want to memorize what the formulas in the book are, that's fine. I don't have the brain power, so what I do is I factor out the 16, 1 minus u squared over 16, and then I go through 1/3. I have the integral of 1/4. And then I have du over square root of 1 minus something squared, u over 4. Okay, so I'm going to use that w again. W equals u over 4. Again, if you can do this in your head. You can. So I really have here 1/3 integral now of dw over square root of 1 minus w squared. Okay, so now I can do this. This is 1/3, if I could write, 1/3 inverse sine of something. Don't forget your plus c. I almost did. Okay, so that is of my u, which was u over 4. Now, what was my u? My u, looking back over here, was x to the third. So my u is x to the third. Again, not necessarily something that's on the AP test, but I think a really cool, some more fun, complicated integrations. Okay, example 4. So, oh, this one's another good one. Oh, these are so good. I don't know why I've been scared to teach this for so many years. Okay, so for this one, my u substitution doesn't work. If I make the u what's in the denominator, then my du is equal to an e to the x dx. Well, I don't have that, but I can manipulate this. So let's look at how we can manipulate this. I can write this as the integral, denominator stays the same. On the top, I can do negative e to the x plus e to the x plus 6. All I did was add and subtract an e to the x on the top. I added 0. I haven't done anything. I haven't changed the problem. So then I can set this then. This is where, in my opinion, the fun part comes in. E to the x over e to the x plus 6. So I take and I put, let me do this. What I did was I took and I put all of that together. And then I'm going to take it, I'm going to add in everything else. And technically I still have a dx hanging out there. I'm going to use all the colors. So then I'm going to bring that negative out in front. E to the x over e to the x plus 6. I kind of have that u substitution up there in the top. Plus 1 dx. So I have this here. I'm just going to take it, I'm going to move that over there. So I have my u as my denominator. Du is e to the x dx. So I have the negative integral of 1 over u du plus the integral of 1 dx. Okay, well, what does that equal? That equals the negative ln of what I had in there. My u was e to the x plus 6. Guess I don't really need those absolute value signs. The antiderivative of 1 dx is x. Don't forget your plus c. Okay, this next one. Now again, I think this is a very appropriate question, especially for an AP test. So, I don't know what that was. So I think this is a very appropriate question. So make your u what your exponent is. So if I make my u negative 3 cosine x, my du is negative 3. The derivative of cosine is the negative sign. So that's 3 sine x dx. Okay, I just need a 3 inside, 1/3 outside, 1/3 integral of e to the u du. So that's 1/3 e. That's always my favorite integral. Plus c. So that was one that, quite honestly, we've seen before. I'd expect you to be able to do that one at this point. And the last one. And quite honestly, I also do this one. I talk about this one when we do some integration. Okay. Our tangent. Tangent, the identity involving tangent and secant. If you don't remember, look it up. That turns into secant squared 2x minus 1 dx. What function's derivative is secant squared? Well, that's tangent. I'm going to skip over my u substitution. This turns into 1/2 tangent of 2x minus x plus c. Do you remember my plus c on the other one? I did. Okay. Sorry, I had to go back and make sure. So I would expect you to be able to do all of these. I think these are all pretty good integrations. A lot of them are using some cool u substitutions where you have to do a few u substitutions twice. Thanks for watching.